Welcome to the online lectures of software engineering. This course is for computer science engineering students, third year, fifth semester. We'll be starting with the introduction to software engineering. Now, before studying software engineering, we will identify what the term software engineering means. Now, the software engineering word, it is made up of two different words. Now, first we'll study what each term means separately, then we'll combine them and get to know what software engineering is. So in here, we very well know that software, it is a set of instructions that why we write a set of instructions so that we achieve a specific functionality. You write a few lines of code, you get a specific functionality. Whereas in engineering, you have a set of principles that is going to be used to design a particular application. You're going to have knowledge. You're going to, based upon that knowledge and principles, you're going to build that application and you're going to analyze objects. So in here, we know what software and engineering means. Now we'll combine the two definitions and we'll come to the term software engineering. So software engineering, it is the use of sound engineering principles in order to obtain an economical software. Now economical, it is inexpensive. That is reliable. Reliable means we can depend upon that software, and this works efficiently on real machines. So we very well know in now what is software engineering. By software engineering, we are going to make use of some certain principles so that you achieve a software that is cheap and on which you can depend on, and it works efficiently on real-time machines. Coming on to the course outcomes, that is, what are we going to learn when we complete this entire study of the subject? Now, as you know, software engineering, you know that in here, acquiring the working knowledge of alternative approaches and techniques for each phase of software development. Now, in here, while you're developing a particular software, each and every organization have got their own techniques and own methods in which you are going to develop a particular software. There are different models, so that in here you get to know what are the different options that are available. The first outcome. Whereas second outcome is what are the skills that you need to have so that you can develop an entire project on your own. You get to know that. And then the third outcome is understand the practical challenges associated with the development of a significant software. Now, as easy as it sounds that developing a software, you're just going to write a few lines of code, debug it, test it, and the software is going to be ready. In here, you're also going to face some challenging issues. You might have some bugs that one functionality might affect the other functionality. So in here, you can identify what are the different challenges that you're going to face in a particular software while you're developing. Now coming on to the next slide, in here within this software engineering course, within the first unit, we are going to have like 3 different chapters. Within the first chapter, you're going to study about a generic view of a process. Now in here, process basically in here means what are the different tasks that you're following, or what is the order of the tasks that you're following. You're going to learn a software engineering, the process framework, CMM model, and process patterns. Now in here, as we're studying about a generic view of the process, now in here within every process you're going to have different patterns that are different techniques that can be used to achieve a particular software. Then process assessment, how you're going to assess a particular process. This is the first chapter that we'll be covering. Then coming on to the second chapter, you're going to study several models that are followed for developing a particular software. You got a list of models that we are going to study. Whereas the third chapter, it is an agile view of process. Now in here, many softwares that are being developed, they are based upon this particular approach, agility. So you're going to study all these agile models also. Now in here, why software engineering is important, why this particular subject is added into the curriculum. Now this particular subject is added into the curriculum because by studying software engineering, it is going to enable you to, that is, you can be able to build complex systems. Complex means a bit difficult systems in a particular timely manner. That is why the study of software engineering is important. The first one. Whereas the second one is you're going to have an surety of a high quality software. Now, whenever you're developing a particular software, the main thing that you're going to focus is your quality. So that is why the study of software engineering is important, so that you can develop a software that has got the best quality. And the third one, and the most important one, is it imposes discipline to work. Now in here, as you've got a list of principles and practices, this principles and practices, they impose discipline among the staff members, how you're going to build a particular software. All the teams are going to be organized and they are going to work in an efficient manner. So these are the three things why software engineering is important. Now the main objective of studying the software engineering is that when you are making a particular software, you can have a software that is maintainable. Now in here, the software that it is maintainable in here, it means that the first one is maintainability. Now in here, when you have a set of requirements that are going to change, that is whenever you have decided to make a particular software, you have got a set of requirements. Might be next day another idea pops up into your mind and you want to change this particular requirement. So in here, the study of software engineering, it provides you with maintainability. You can embed changes within the software. Then you can ensure correctness of the software, that is, it is going to give you correct output. The next one is reusability. Now within reusability, in here, a particular software is made up of different modules, or we can say that different components. In here, if suppose you're making a similar type of software, you can reuse that particular components in another software by making small changes. Then you also have as testability. Now, whenever you're developing a software, the main criteria is that you test that this particular software is working properly or not. You're going to make a testing criteria. That is what is going to be the output based upon a particular input. You're going to test the entire software. Then reliability. What is reliability? Now in here, reliability means now a particular software, when you're giving a particular input, it is going to ensure that you get your desired function as your output. Desired function should be your output. That is, your software should be reliable. Then it should also be portable. Portable means it should be a portable software that can run on different operating systems. Then the next one is adaptability. Now within this adaptability, the software allows the system and the user needs to be satisfied by making changes within the software. That is, in here, the first one was requirement change. Within this adaptability means these changes will be made by the developers so that the end user is satisfied. That is, the customer is satisfied. Now in here, two terms that we need to remember while studying software engineering. Now in here, there are two persons. There is a customer that is going to use the software, and you've got a developer that is going to develop the software. Now in here, the developer in software engineering will be called as stakeholder. Stakeholders are the people that are going to be benefited by the software. And the customers in here will be called as end users. The people that are going to make use of this particular software. These are the end users. Now, let me also give you a few examples of stakeholders. Now, the stakeholders in here, stakeholders, it can be a manager, it can be a particular organization, it can be a particular software, it can be a particular engineer. So these are the examples of stakeholders. For the term developers, we'll be using stakeholders. For customers, we'll be using the term as end users. The two things we need to remember. Now we'll take a small example of how an engineer is going to solve a particular problem. The 4 steps for solving a particular problem. First one is understanding the problem. Now in here, whenever you're going to understand a problem, means a particular customer is going to come and tell you that this is the type of software that I want this type of particular software. So in here, when you know what the problem is, you are going to identify what are the different features the particular end user wants within the software. Then the second thing that you'll be focusing on, that can these features be represented graphically. Now in here, you want the features to be represented graphically because many times an end user comes you with ideas, but he might exactly not know how it is going to be implemented. So when you implement it graphically, it becomes more clear for the end user and the stakeholder. That is, all your ideas are going to be cleared. You'll have a clear view of what is going to be developed. That is the first step in understanding the problem. The second step is planning the solution. Now in here, when you're planning the solution, you're going to identify that whether this particular solution that you're running, whether you have encountered a similar problem. Now, if suppose you have got a similar problem previously, then you can reuse this. Now, the main thing in software engineering is that whenever you're developing a particular software, sometimes you might develop more number of modules, more components are developed. So when you have these components already developed, or suppose if you have only one extra piece of software that has been developed, one component was developed. So in here, by making small changes within that software, you can again relaunch that software. So in here, the main thing is whenever you've got a similar problem, you can reuse the component. Now, when you're reusing the component, the main thing is that you can save time. That is why you're going to check whether you have encountered a similar approach before or not, so that you can reuse the particular solution. Then the next thing that you're going to do is that when you know there's a particular component can be reused, you can also going to identify whether this particular problem, it can be divided into sub problems. Now, when it is divided into sub problems, it becomes easy to work, so that you can easily work on the software. That is why you're going to plan the solution. Then the third step is carry out the plan. Now in here, when you've identified the reusable components, you've got sub problems in it, that is, you can divide it into multiple parts and work. You are going to make a plan. You're going to have a schedule in which you're going to work on, and you're going to start implementing the software. Then when you're implementing the software, in here, each and every team is making a component. That is, they're working on one part of the solution. So in here, you're going to check that is each component part of the solution is probably correct. That is, in here, you're going to map whether this particular component is matching the features or not. It is necessary that the component that you are developing, it should give the particular feature that the end user had requested. Otherwise, developing this particular software might go to waste. Then the next thing is you're also going to check that the source code. Now, whenever you're designing a particular software, you're also going to do the coding part. This source code, it should be traceable to the design. Now in here, whenever you're implementing the source code, you're also going to check whether all of these components are there within the design. That is, whenever you're developing a software, you're going to have an architecture, whether all of the things are matched within the design. Then the fourth one is examining the result. Now, examining the result is, in here, it basically means testing. You're going to test the particular software. You're going to identify, does this particular solution that you're producing, it gives you the particular result that the end user wanted in the first place. You're going to examine this result. So these were the basics that we've covered for software engineering. Now moving on to software engineering as a layered technology. Now this answer is important for 2 to 3 marks for layered technology. Why software engineering is called as layered technology. Now the software engineering, there are 4 layers in the software engineering layers. You've got a quality focus, you're going to have process, methods, and tools. Now in here, within the software engineering layers, the first layer is called as the quality focus. Now in here, the quality focus in here, it means that the particular quality focus, it is going to act as your bedrock. Bedrock, you can also call this as a foundation of software engineering as a quality focus. You need to know what you are developing. Until and unless you do not have a clear idea of what you have to develop, it is waste to identify the other plans for the particular software. So quality focus, it is an engineering approach that must have a focus on quality. You're going to identify what is your focus, and whatever you're developing, it should ensure the best quality. If you're just making a software that has got no quality, then it is not going to make its sales within the market. Then the next one is a process. What is a process? Now this process, within this process, you're going to identify what are all the different tasks that are going to be added within this software engineering. What are the different tasks that you're going to perform so that a particular product is being made? What are the different tasks that are going to be? Now, one more thing is that this particular process, this is going to act as a glue between all these layers. That is all. You can have all these layers connected. This process ensures this. Now, in here, the in the foundation of software engineering, you've got technical methods, work products, and changes managed. So in here, what are technical methods? Technical methods are are the different methods that you're going to use that are going to be identified. The different methods, that is a different layer. But in here, you're also going to first identify what are the methods that you're going to use. Then you also have the work products. Now in here, work product in here means that work products means that it can be a particular document, it can be a file, or what type of data you're using. That is called as work product. Then changes manager, if suppose you want a change within a specific feature, then how you're going to embed that. That is going to happen within the process phase. The next layer is methods. Now within this method phase, it basically is going to provide you with technically how-tos for building a software. Now in here, how to means how you're going to develop a particular software. That is going to be identified in here. Now in here, there might be more than one technique for developing a specific software. You may have more than one technique to develop a software. So between them, you're going to identify which is going to best suit the particular application that you're developing. Then the last phase is the tools. Now in tools, you're going to identify the tools are going to provide support for the process and method. Now tool in here, if suppose you want to write a C program, for writing a C program, you might require a Turbo C++ or DFC. That is the software, that is the tool that you're going to use. In software engineering, the tools that you use are called as the case tools. CASE. That is called as your computer aided software engineering tools. These tools are going to help you design a particular software. Now, moving on to the next topic, that is a process framework. Now, in here, this process framework, it acts as the foundation for the entire software process. This process framework, this is going to act as your foundation. Now, in here, you might be wondering what is framework. Framework in here, it means like the structure of software engineering. You're going to have a frame in which you're going to work. So this process framework is going to make use of umbrella activities, and umbrella activities is going to make use of software engineering actions to complete a particular task. So whenever you're designing a software process, you're going to make use of umbrella activities and the framework activities. Within this framework activities, you've got a list of software engineering actions. Now in here, we'll just zoom in. What is a software engineering action? Now in here, what happens is that when you've got one particular task, like in a textbook also, you've got one particular main topic as mentioned as, suppose, framework activity 1. This can be your one particular task. This framework activity is your main heading. Suppose this is your one task. To complete one particular task, you need to follow a set of actions. Now within this task, you're going to have 4 tasks, work tasks. Now within this work tasks are the different tasks that you're going to do so that a work product is being developed. Now, as I told, what are work products? Work products, it can be a document, it can be a file, it can also be a report, or it can be any type of data that you're using. What type of data this particular software is going to ensure. Whenever you're writing it down, you're documenting it down, that is called as work product. Now, let's take an example. Now, in here, first, suppose a customer is going to come and tell that I want a software to be developed. So in here, the first step that is going to happen is the communication phase between the end user and the stakeholder. Within this communication phase, what is going to happen? The developer is going to ask questions so that you can clarify what are the different features they want. So within this communication phase, what you're going to do, you are going to gather a set of requirements. So my work task is communication. Now, when I'm doing communication, I'm gathering a list of requirements that are going to be added within the software. Now, when I have all the list of requirements that the end user wants within the software, I am going to document all of them in a file format. Now, documentation is very important so that if suppose a meeting is going on, you do not take down any notes. There is a chance that you might forget a particular point. You might forget a particular feature, or the end user might say that he might have added some point and you did not remember. So that is why a work product, writing, documenting, all of this is very important. Then the next one is quality assurance points. Now, as I told you that ensuring the quality is the main criteria, because if suppose you do not have a best quality software, then it won't be able to survive in the market. So that you gain profit from the software, it is necessary that you have the best quality software. That is why you're going to ensure the best quality. Then you've got the last stage as your project milestones. And the project milestone, that is, what are the milestones that you're setting for the particular software. First, you want all the requirements to be documented. Then you want the design. Then you want the coding part, testing. Then the entire software be completed. Then you're going to test it. After testing, there might be a chance for improvement or optimization. That is going to be identified within the project milestones. So these are a set of activities. Now in here, you can see that these actions are repeated again. for all the set of activities from endpoint 1 to endpoint m. That is how many tasks you have, that is going to be repeated till that particular point. After that, it is going to end. So we have first studied the framework activities. Now after the framework activities, we're going to go to the umbrella activities. The umbrella activities that were supporting the framework activities. Now these umbrella activities, this are used as a basis for the description of all the process models. That is, it is going to describe all of these models. The first umbrella activities is called as the software project tracking and control. Now by the name itself, we can identify what is software project tracking and control. Now whenever you have an end user come to you and discuss a few features that you want within the software to be developed, you are going to make a plan. Now whenever you make a plan of the software, whenever you're making a plan, you are going to have a schedule on which you're going to work on, the specific timings, the hours that you're going to work on. Now when you've decided, you've made a schedule, you're going to check whether each and everyone is following this particular schedule. That is, you're going to keep a track of the schedule. Now if suppose when someone is falling short of this, that is, if suppose one particular module had to be completed till the day end and you're falling short of time, you're going to control it. How you can control this? By working overtime. Or if suppose that particular activity requires a lot of time, then you might also add a particular person. One more person can be added to complete the task so that the task is completed. That is how you're going to ensure the tracking and control of the project. Then you've got this risk management. Now in here, risk management means whenever you've got an idea of what are the different features that are to be embedded within the software, you're also going to identify what are the different risks that you might encounter. Now, these risks are going to be identified prior to testing, because when you know that this problem might occur, it will be easy for you to remove that particular bug. Then later than panicking and identifying that this is the error that you've got. So within the first stage, you know that this risk might occur. You may have different ways of how you're going to remove this particular bug from the system, or how you're going to avoid that particular risk. You can completely avoid the risk, or it will be easy for you to debug the software. Then the next one is software quality assurance. Now within the software quality assurance, you're going to have some specific metrics, so that you can identify. Now what are you're going to have metrics? As I said that you're going to have metrics in here. Now metrics in here, it is like some specific standard. You're going to have standards in which you're going to measure the quality. If it reaches some specific standard, how you're going to measure it. Now if suppose you go for this logistic department, you've got the delivery time. Now if you ordered a particular item from you added a particular item either from Swiggy or from Amazon, there is some specific delivery time. Based upon that delivery time, you can identify what is the quality of service. So based on that, you can identify the software quality assurance. Then you've got is formal technical reviews. Now in here, within the formal technical reviews, and here by the name itself, reviews means you're going to have different technical persons that are going to help you to uncover and remove errors. You can uncover the error, that is a few hidden errors, and you can also remove errors before they are affecting some another action. You're going to uncover and remove errors before it is going to affect your next action. Now in here, before it affects your next action, in here means if suppose there is some small mistake within the first part of your program, it might just give you errors in different lines of your program. You're going to have different errors shown in different lines. When you check that particular line, there is no error in there. But that one particular error is causing errors in the different lines. That is why you're going to uncover and remove errors before they are going to affect the next action. Then you've got the software configuration management. Now in this configuration management, you're going to manage all the effects and changes. You're going to have all the software configuration settings, the hardware configuration. That is, what is the effect of the software, or what are the changes within the software, how they are going to be managed, that will be identified by software configuration management. Then the next one, last, is work product preparation and production. Now, what are work products? Work products, it can be your documents, it can be files, reports, data, all the things that are written down, that are your work products. How you're going to prepare them, and then how you're going to create the models. Now, normally for this, all the umbrella activities are applied. The next one is the generic process framework. Now, within this generic process framework, you've got 5 different activities. Within the generic process framework, you've got 5 activities, that is communication, planning, modeling, construction, and deployment. Now, these 5 activities, they are going to be used in many projects. These activities are used basically in all the projects, or the projects, they are going to follow this type of, all these 5 are somehow followed in all software projects. Now, the very first stage is communication. You're going to have is a heavy communication between the 2 teams, that is your end user and your stakeholders. Now, this communication, you're going to have all the list of requirements that the particular end user wants within the software. You can also say these requirements as your features that are to be there within the software. By doing communication, you can gather all the set of features or requirements that the customer wants within the particular application. Then the next phase is your planning phase. Now, within this planning phase, you're going to identify what are the different tasks that you need to perform so that the particular software is being developed. Then you're also going to identify what are the different risks that might appear. You're going to identify the risks beforehand, the risks that might appear within the software, and you're also going to identify what are the different resources, or how many resources that are going to be required for developing the particular software. If suppose you've got like 5 members within the team, 5 members, they want access to resources, like they want the particular software and they want their specific systems and their tools to develop the particular software so that you can produce your work products. And you're also going to identify how there is going to be a workflow. Workflow means how first gathering the requirements is your first stage. Then planning the tasks might be the second. Then identifying risks is third. Then identifying the resources. What is the order you're going to identify within the workflow? That is the planning phase. Then the next one is modeling. Now within this modeling phase, modeling is divided into 2 phases, that is analysis and design. Now within this analysis phase, we can say that with an analysis, if suppose you've got all the requirements, you've got all the requirement gathering is done. Now when you've got all the requirements, you might also want to elaborate all of this requirements. Elaborate means what this exactly means. You might want to know what this exactly means, so that there is no so that you develop exactly what the end user wants, that you do not make any mistakes. Or you can also say what are the different specifications the end user wants within the software. Then coming on to the next part of modeling, that is design. Now within this design, the design part is within the designing phase, you're actually going to make an architecture design. Within the designing part, you might make an architecture diagram or like a blueprint of the software that you might want. So in here, you're going to identify what is the type of data that you're going to use, what is going to be the user interface you're going to identify, and what are going to be the different components that are going to be there within the software. Components are basically parts. What are the different parts this particular application will be made of? Then coming on to the fourth part, that is construction. Now the construction part, it is an easy part. This construction part, it is going to tell you that this in here, you're going to have coding part plus the testing part. You're going to write lines of code. You're going to coding as basically programming. You're going to write programs and then you're going to debug them. You're going to test whether it gives you the specific functionality or not. The specific functionality that was desired by the end user, specific functionality that the end user wanted, that is going to be checked in here. Then the last phase is the deployment phase. Now as everything is done in here within the deployment phase, what you're going to do is that the software product, this is going to be delivered to the end user. You're going to do is deliver this to the end user. Now in here, when the software is being delivered to the end user, he is going to work upon the software. He might get to know if suppose there might be a few changes are required. Suppose that can be like, you can say that feedback. The customer is basically going to give you a feedback. Based upon that, if so, you might also give some updates onto the software. When a particular software is being developed, you're going to provide with support, providing timely updates to the software. This is the generic process framework. We need to remember these 5 stages. These 5 stages need to be in an order: communication, planning, modeling, construction, deployment. You can remember this as C, P, M, C, D. Now remember, 2 C's are there. First one stands for communication and the fourth one is going to stand for construction, because this phase are going to be used in a few more models within the second part of the within the second chapter that we are going to study within the first unit. With this, we are going to end the class. Thank you.